Okay, so now that we know how to simplify rational expressions, the next thing we're going to learn is how to multiply. What you'll see as we go through this series of videos is that we're going to work with fractions starting from the easiest process up to the most difficult process. So in every single problem, you might remember from when you did fractions in elementary school, in every single problem, you're going to need to be able to simplify the fractions. So that's why we start with simplification. Then the next easiest thing after that is multiplying. And so that's what we're going to talk about in this video. Multiplying with a rational expression that has variables is the exact same process as it was when you had numbers. There's nothing that's different. The only change will be the way that we simplify, and we covered that in the last video. Okay, so with that said, let's get started by taking a look at today's learning objective. Again, there's only one. That learning objective is that you be capable of multiplying two rational expressions together. All right, so just like we're doing in all of these videos, let's start by revisiting a problem that you would have done back in elementary school. So in elementary school, you would have talked about how to multiply 5 over 6 times 4 over 7. Okay. In fact, you probably learned two different ways to do this. And so I'm going to consider two different ways to do this because I'm not sure which one you would choose to do. So method number one, method number two. Okay. So method number one is probably the method that you learn first. And method number one is where you multiply straight across. So I would do a 5 times 4, which is 20, and a 6 times 7, which is 32. No, 42, excuse me, 42. Okay, so I would just multiply straight across. Then I would simplify. So both of these things are divisible by 2. So 20 divided by 2 is 10. 42 divided by 2 is 21. And there's my answer. So method number one is to go multiply across first, then simplify. Okay, so maybe that's the way that you like to do it. Other people like to use a different method where they simplify first using a process called cross-canceling, or whatever your teacher called it back in the day, and then they multiply across. Okay, so that's just another option. It's up to you. So in this method, what we would do is we would say, okay, look, I know that 4 and 6 are both divisible by 2. So I'm going to divide them both by 2. And then I'll multiply across. So 5 times 2 is 10. 3 times 7 is 21. So notice in both cases, I have the exact same amount of work. Here I multiply first, then simplify. Here I simplify first, then multiply. In both cases, I get the exact same answer. So it really truly makes no difference how you do it with numbers. But here's the thing that I want to remind you of. When it comes to variables, we are not super gifted with our times tables to just be able to look at 4 and 6 and know they divide by 2. That's easy to do with numbers. When we slap in variables, that's hard to do. And so what I'm going to recommend is sort of a kind of a modification of method number one. We're basically going to do method number one, but in the across step, we're going to do like across light, okay? What I mean by that is we're not going to fully multiply it. So let's actually do an example so you can see exactly what I mean. All right, so let's take 3x plus 6 over x minus 1. And let's multiply that by 2x minus 2 over 6x minus 24. Okay, so the first thing that I'm going to do is multiply across, okay? But I'm saying across light. Here's what I mean. I want to go across and make two sets of parentheses, but I'm not going to actually multiply the two sets of parentheses together. I just want to get a bunch of stuff in the top of my fraction. And then I'm going to do the same thing in the bottom. So functionally, I haven't changed anything except I've made one great big fraction. That's all I've done. So it's actually even easier than what we did with numbers, because with numbers, we had to actually multiply them. So that's the first thing I'm going to do is I'm going to combine across into one big fraction. Then I'm going to simplify. And at this point, it's exactly the same as what we did in our last video, where we take each of the polynomials and we factor them. So I'm just going to look at them one at a time. Here's my first polynomial right here. I notice that there's a 3 and a 6 in that polynomial. So that tells me that I can divide or factor out a 3. That's going to leave behind an x plus 2. Okay, now here's my second polynomial. I'm going to try to factor that. I notice there's a 2 in both spots. So that tells me I can factor out a 2, and that's going to leave behind an x minus 1. Down in the bottom of my problem, here's polynomial number 3. There's nothing that factors in that, so I just write it down. And then lastly, here's polynomial number 4. That has a 6 and a 24 that I can divide both things by 6. And so there's what I end up with after I'm done factoring. Now I go through and I start canceling out things that have in common. So there's an x minus 1 in the bottom, and there's an x minus 1 in the top. Those can cancel. 2 divides into 6, so I can cancel the 2 with the 6. That leaves a 3 in the bottom. But then 3 divides 3, so those cancel out. So ultimately, when the dust settles, what am I left with? Well, in the top, the only thing that's left is this x plus 2. And in the bottom, the only thing that's left is that x minus 4. And so there is my final answer. Okay, so my basic process is I combine this together into one great big fraction just straight across. So I'm going to call that combine across. Because I'm not actually truly multiplying stuff together yet. It's not like I FOILed these out or distributed or anything like that. And then after I combine across, then I simplify. And with simplifying, we're going to do that exactly the same as yesterday. We're going to look for GCFs first. Then we're going to do other methods second, like for example, grouping or our difference of squares or something like that. And then we know we're done when nothing else factors or cancels. Okay, so that's the stuff that we talked about in the last video. If you need to review the last video for that, go right ahead and do that. All right, so let's wrap this video up by doing 1 or 2 more examples of this. So here is example number 2. In example number 2, we're going to take an x plus 3. X plus 3, this is all, let me rewrite this. X plus 3 over 2x plus 4. Okay, so there's one fraction. And I'm going to multiply that fraction by an x squared plus x minus 12 over x squared minus 9. Okay, so we've got our basic procedure that we've just outlined on this other page. We're going to combine across without actually multiplying. We're just going to make one great big fraction. Then we're going to simplify by going through all of the individual bits and pieces and trying to factor both with greatest common factor and with any other method that works. Cancel out stuff that is in common, and then we're done. Okay, so maybe pause the video and give that a try right now. All right, so hopefully you tried that. So what I would do when I combine across is I would start by taking the stuff that's in the top and putting it into the top of one great big ugly nasty fraction, and then take the stuff in the bottom and do the same. So that would be my first step. Then I'm going to go through each one of these things one at a time and try to factor them. So there's my first thing, x plus 3. That does not factor. So I just bring that down. Then I come over here to x squared plus x minus 12. That one I think does factor, so let's try it out. 1 times 12 is 12. The factors of 12, 1 and 12, 2 and 6, 3 and 4. The pair that subtracts to equal 1 would be 3 and 4. And I want a positive 1, so it's got to be 4 minus 3. So I'm going to rewrite with a 3 and a 4 minus 3. Now from the first group, my greatest common factor is an x. From my second group, my greatest common factor is a negative 3. So I end up with an x plus 4 that they have in common and an x minus 3 that's the piece to which it was distributed. So factor number 2 here breaks down to be an x plus 4 times an x minus 3. All right, so I've got the 2 in the top done. Moving on to the bottom. In this one, both of my terms can be divided by 2. So I'm going to use greatest common factor to take out the 2. That leaves an x plus 2. And then last but not least, in this one, both of my terms are squared. So that tells me I can use the shortcut. So I'm going to take the square root of x. That's x. Square root of 9. That's 3. And I'm going to write that twice, once with a plus sign and once with a minus sign. So now we've got all of those things factored. What comes next? We're going to cancel anything that's common. So there's an x plus 3 that's common. There's an x minus 3 that's common. And that's it. Because remember, we can't cancel things that are locked together by plus signs. So I can't cancel this 4 with the 2 or anything like that. Those do not cancel. So my final answer becomes the x plus 4 that's left in the top and 2 times x plus 2 in the bottom. Okay, so that would be my answer for example number 2. All right, so that's our basic process. I'm going to stop this video here. I might make a second video that has 1 or 2 more examples just so you can see a few more of these, but they're all going to be the same basic process. We start by combining across. Okay, so that's what we said we were going to do first, combine across. So in this particular problem, I combined across like this. On the other problem, I combined across like this. Then we go through each of the different things and we try to factor them using greatest common factor first and then any other method that works. So in this one, we had lots of methods. We got greatest common factor, but we also had to do grouping and we had to do a difference of squares. Okay, once we've got everything factored and we cancel everything that matches, then that's when we're done. All right, so hopefully you found this helpful. Thanks for watching. Be sure to tune in to the next video where we go through some more problems. Have a good day.